Okay, so we've actually reached the end of chapter 5. This is our last lesson, kind of combining a bunch of different things together for this practice. So we are going to look at adding and subtracting polynomials. We are going to look at using brackets and different variables. And so we're going to show adding, and then we're going to show collecting like terms. So keep in mind why brackets are used. So brackets are usually used to show that something goes together, or we can use it to make sure that a bunch of terms are multiplied by a coefficient or something like that. But brackets usually are there for a purpose. If the brackets are no longer serve a purpose, we don't need to include them anymore. Okay, so when we look at these examples, I want you to keep that in mind, that the brackets may not actually be serving a purpose, and then we don't need them anymore. So when we look at this first example, we have 3x minus 4, and we have 2x plus 5. So what that could be is maybe we're looking at two side lengths, and we're going to add them up. So we have a length of 3x minus 4, and we have a length of 2x plus 5. Excuse me. So if we're going to add these, right now the brackets don't serve a purpose other than to say that one length is 3x minus 4 and one length is 2x plus 5. So we can rewrite it like this: 3x minus 4 plus 2x plus 5. And nothing has changed. And so then from here we can go on to group our like terms. So we have 4 terms, we have 2 x terms and 2 constants, so I'm going to add the x's first, and we get 5x. And then we have negative 4 and positive 5, so there's going to be a positive 1 left over, so 5x plus 1. Sorry if it's getting quiet, I'm actually really losing my voice right now. Let's look at the second one. So in B, again, the brackets aren't serving a purpose other than to say these first 2 terms went together for something, and then these 3 terms, these last 3 terms went together for something. Maybe, again, it was 2 different lengths or something, or 2 different piles. Basically, this is saying, like, this is pile A, and this is pile B. These are mine, these are yours. Doesn't matter, we're putting them all together anyway, so we can drop the brackets. Okay, so then separate into like terms, and then group our like terms. So 3x squared plus 1x squared gives us 4x squared, negative 5x, and positive 2x. There's more negative, so negative 3x. And then lastly, there's only one constant, so plus 1. Okay? I hope you're getting really good at these and you're starting to like them. I think they're fun. Maybe that's just me. So we're going to do the same thing again. We're going to add these polynomials. So we have, 2a minus 1 in one pile and 6 minus 4a, and we're just going to put them all together by adding them up. So we can drop the brackets. There's no reason for the brackets in these examples other than just for you to get used to seeing brackets. So separate, whoa. Oops. There we go. That looks better. And then, so on our like terms, we have the a variables. There's more negative than positive, so negative 2a. And then negative 1 and positive 6. There's more positive, so positive 5. Looking at the next example, again, we're adding 2 separate piles. So 2x squared minus x plus 3 plus x squared plus 3x. Separate into terms. Combine like terms, starting with the highest exponent, 3x squared plus 2x plus 3. If you're struggling with those, please come see me, because it's about to get a lot harder. Well, like a medium amount harder. Okay, so when I say the opposite, it's like if I'm saying the opposite sign. Or if we were on a number line, what would be at the opposite position? So if we have positive 3x, the opposite is negative 3x. If we have negative 2, the opposite is positive 2. Okay? If we have 4x minus 1, we're going to take the opposite of each term. So negative 4x and positive 1. Both of them switch terms, switch signs. Same thing if we have 3 terms. Negative a squared plus 3a minus 2. So all of the signs change. This is going to be really important for what we do next. So, sorry, I think this copied out kind of light on your notes. So instead of subtracting polynomials, we can actually add the opposite. So I'm going to build these out and show you them as a subtraction, and then I'll show you how adding the opposite is the same thing. Okay, so if we look at the first example build, I've built 3x and I've built negative 4. And so it's saying that we need to take away 2 x's. So take away 1x, take away 2x, and then we need to take away 3. So 1, 2, 3. And when we do that, we're left with x and then negative 1. Okay? So let's put those back. Oops. Okay, I moved them all back. And so then it says, oh, I did that wrong. Just kidding. We can't do that. You know why we can't do that? I hope you notice why we can't do that. I don't pay attention. So we need to take away 3 positive ones. But we don't have 3 positive ones. We only have 3 negative ones. So this doesn't work. So we need to think of adding the opposite. Okay? So I'm going to move all this out of the way. So we're going to have 3x minus 4, and we're going to add the opposite of 2x plus 3. So we're going to add negative 2x and negative 3. So the opposite of positive 2x is negative 2x. The opposite of positive 3 is negative 3. So we get 3x minus 4 minus 2x minus 3, because adding a negative is just the same as subtracting. Now we can combine like terms. So we get 3x minus 2x. So that worked out okay. We got 1x, the same as when we were building it. But now when we're looking at the ones, negative 4, take away 3 more, is negative 7. That makes more sense. And let's look at the second one. 2x minus 3, take away negative x plus 2. Well, we can't take away a negative x from positive x. So we can't take away here if we were to build it. So we need to think of adding the opposite. So 2x minus 3. So we're going to add the opposite of this. So negative x becomes positive x, and positive 2 becomes negative 2. So we get 2x minus 3 plus x minus 2. Separate our terms, and then we can combine like terms. So 3x, take away 3 and take away 2 more. 3x minus 5. I hope I haven't just blown your minds. Don't worry, I'll show you these 2 examples too, because these look a little crazy. They're not crazy, they just have more terms. So, again, the brackets, and now the brackets in this case are saying that everything behind them is being subtracted. Everything in this term needs to be subtracted from, in this polynomial needs to be subtracted from the first polynomial. So everything is being subtracted, which means everything, we're going to add the opposite. Everything is going to flip signs. So 3x squared minus x plus 4. Because everything behind the subtraction sign is what we want to take away, we're going to add the opposite. So we are, instead of positive 2x squared, we think of negative 2x squared. Instead of negative 3x, we think of positive 3x. And instead of negative 1, we think of positive. So they've all flipped. Separate our terms and then find the highest x first. So we have x squared, 3x squared, negative 2x squared leaves 1 positive x squared. Negative x and positive 3x leaves us with positive 2x. And then the constants give us plus 5. I'm looking at the last one. We have two trinomials. The second trinomial is being subtracted from the first. So we're going to flip the signs, or we're going to add the opposite. So positive 2x becomes negative 2x squared, negative 2x becomes positive 2x, and positive 4 becomes negative 4. Separate the terms. Negative 3x squared, negative 3x, negative 6. Okay. Please come see me tomorrow. If any of this does not make sense for you, we will do a bit more practice, and we also will do a bit more with our polynomial Uno game, which hopefully should help you.